All right. So the one thing I noticed about this SAT non-calculator portion was that I found myself doing a lot of like tedious work for this one. And that's just important because it's really important that when you're doing the non-calculator portion, even though you don't have a calculator, you just still know how to do the tedious work, even though we always want to do it in the calculator. So it's good to kind of speed through the ones you know, as I've been saying, just because the tedious work does take a little bit of time. So I'm going to start and do everything on this page just because whenever we do this portion, I normally can finish most of the problems. So let's look at number 1. It says, the equation above relates the number of minutes, X, Maria spends running each day, and the number of minutes, Y, she spends biking each day. In the equation, what does the number 75 represent? So I know that this equation itself is kind of like in a weird format, but if you think about it, all they're doing is from the stem of the problem, they're adding the minutes of running, because X is running, and they're adding the minutes of biking. And when you add those together, you get 75. So the answer is, it would be C. Because if you add both of these together and you get 75, that means she's spending a total of 75 minutes running and biking that day. Total is adding up, and that should be the key word for that problem. So that one wasn't too bad, just kind of weird because we normally don't see problems in this form unless we're doing a different type of equation. So number 2, which of the following is equivalent to 3 times x plus 5 minus 6? This is just simplifying. It should be very, very simple. But of course, if you need a review on it, that's fine. You distribute the 3 to that the one inside the parentheses. You get 3x plus 15, and then all you have to do is combine like terms. You get 9. So those two, at least number 1 and 2, were not bad at all. So let's look at number 3. It says, which ordered pair x comma y satisfies the system of equations shown above? So system of equations is basically just finding the point or coordinate that will go into each and work for both. So let's see. It says, which ordered pair satisfies the system equation for both? So at least for this one, I think the easiest method of doing this is through substitution. You could always do it a different way, but through substitution, at least, since we know that x is equal to y minus 3, all you have to do is plug that in to the x in the second one and then solve. And then that's how you find the answer. There are many ways to do a system of equations, but for this one, substitution I think was the best way. So now at this point, it would kind of benefit you if everything on this side over here had the same denominator. So what I'm going to do is put y minus 3 over 2. But in order to make the 2y have a 2 in the denominator, I'm going to make this 4y over 2. And you do that by just multiplying 2 over 2, which is the same thing as multiplying by 1. But that's kind of how you get the same denominator. And the 6 stays there. You combine them so that they have the same numerator, and then you end up getting 5y minus 3 over 2 is equal to 6. I'm going to erase this stuff over here and continue to work on the left. When you do that, you end up getting, sorry about that, 5y minus 3 is equal to 12. You can move the 3 over here and get 15. And when you divide, you get that y is equal to 3. So that means that when you plug in 3 into both of these, you're going to get the same answer for x. Now, and that also means that in our coordinate over here, even though we're not sure what x is, it means that it has to be 3. I always like to just find the x just to be sure, but this is a time-constrained test. So if you look at the answer choices, there's only one that has a 3 in the y section, and that's B. So you can just go ahead and stop right there because that's the only possible answer, because 3 is y and none of the answers also have 3. I would assume that the SAT would actually just instead of having a different y for each answer, they would actually put some with the same y. Like for example, they'd put 3,3, just because they kind of want you to do it like the full way through and not just stop right there. But at least for this question, you could do that. I saw some questions in the chat box. So yes, so I did multiply times 2 to cancel out the 2. I just there's many ways to do it. I just like to have everything together before I do that step. Which is why I had everything in the numerator first over here. So let's look at number 4. I don't like using green, so I'm going to change the pen. So it says, which of the following complex numbers is equal to all of that? I'm not going to bother reading it. Where I is equal to the square root of -1, an imaginary number. So if you've been going to the sessions for a while, you may kind of see this problem as kind of familiar, but now is when you should know the concept of imaginary numbers. Just to briefly go over it, I is equal to the square root of -1, which is given in the problem. And in math, when you encounter I, they don't like you to simplify it. However, when you have I squared, that's what gives you room to simplify. Because the square root of -1 cannot be simplified. It can't. It's just an imaginary number. However, we should know that whenever we square a square root, we just get the number on the inside. So by squaring the square root of -1, or squaring I squared, we're left with just -1. So that can be simplified and that can be done. So that's why you'll notice that all of the answers only have an I and a regular number, integer. But so they have to do something to get rid of that I squared. And that's what's the most important part of this problem. And it's the first time I've seen a problem like this before. Normally they just ask you to combine. So when doing this, all I would do, and I lost track of the page, all I would do is plug in the square root of -1 into the I squared. I wrote that wrong, sorry. The square root of -1 minus 6i. And now is that's what gives you room to simplify and, you know, adjust the problem. The i's, like I said before, they're going to stay the same. You're not going to do anything to those because they can't be simplified. You just leave them as a number times I. However, I squared can most definitely be simplified. So 5 plus 12i, we have a negative on the outside of this parentheses. Not when you do this, the square root of -1 times the square root of -1 is -1. So this is a -1 minus 6i. When you end up simplifying that even more, I'm going to distribute the negative in the front now. This becomes plus 9 and plus 6i. So now at this point, your answer should be, and I'm going to bring it up over here because I'm running out of space, 14 plus 18i, because all I did was combine like terms, and the answer should be D. So I'm going to go ahead and move along. Remember that if anyone has any questions, pause, tell me to pause, unmute yourself, and I'll feel free to explain it again and help you guys out. But I want to make sure we do as many problems as possible. So yeah, let's look at number 5. So it says f of x is equal to all of that. I'm not going to read it. What is f of -1? All you have to do is plug in -1. And instead of writing each thing and plugging it in, I kind of just do it in my head. So every time I see an x, I'm gonna plug in -1 for it and just rewrite and simplify. So I plug in -1 into x squared, I get 1. I plug in -1 into -6x, I get plus 6, positive 6, and then the plus 3 stays the same. And then on the bottom, it's x minus 1, so it's -1 minus 1. From there, all you have to do is simplify. So you should end up getting 10 on the top, -2 on the bottom, -5. That's your answer. Again, you'll notice that a lot of these can be done very easily. So that's a really good thing about this test. So let's look at number 6. And number 6 was the first one that I kind of saw myself having to do tedious work. There may be an easier way to do it. I just didn't see it in the moment, but I'll show you guys how I did it. So it says, a company that makes wildlife videos purchases camera equipment for $32,400. The equipment depreciates in value at a constant rate for 12 years, after which it is considered to have no monetary value. So basically what it's telling you is that after 12 years, this value of 3,200 is going to be 0. So that's important. That means that it's increasing at a constant rate each year, and constant rate is a very key word, an important keyword in this problem. So it says, how much is the camera equipment worth 4 years after it is purchased? So basically what I did is I figured out how much the value was decreasing per year, and then I subtracted it by 4 years. And that'll become more apparent when I do the problem. So first we have to figure out how much it's decreasing each year. To do that, all we have to do is divide this by 12. And this is the first instance of doing something that's kind of old, because we don't have a calculator to just divide it. So this is a very basic way of dividing that we learned a long time ago. How many times is 32 going to 12? That's twice. I'll just finish solving it. 84, that's 7. 84, yeah. What I'm gonna do is I'm gonna bring it up over here because I keep running out of space. Sorry about that. So let me rewrite it. This goes in twice. This goes in 7 times. And then when you're left, you're just left with a whole bunch of zeros, so just fill in that remainder. That means that it's decreasing by $2,700 each year. It's asking us how much it's worth after 4 years. So we need to do 2,700 times 4 to figure out how much money was decreased within a matter of 4 years. When you do that, you should get 7 times 4 is 28, and 2 times 4 is 8, 10. That means that in 4 years, the price of this camera or camera equipment decreased by $10,800. The last step of this problem. And I'm sure there's a much easier way to do it, but I'm just showing you guys how I kind of saw it. Now we just have to subtract this by that, because it's asking for how much it's worth, not how much the value was lost. If it was, then that would be the answer. When you subtract, it's just very simple subtraction that we learned a long time ago. I don't think I need to explain it, but when you do it, you get C as the answer. Yeah, so I don't know if this was just like put there on purpose to make you do a whole bunch of tedious work, but that's just kind of how the SAT operates. This is the first test where I found many problems having to involve that tedious work. So let's see. Number 7. All right. So it says, which of the following is equivalent to the expression above? So what I noticed about this one, at least, was that you couldn't just like normally factor it out. You kind of just had to like reverse and kind of look at the choices and see which one would give you the right answer. So when I was doing this problem, at first I was inclined to just kind of solve this and figure out which one gave me that. But after looking at the answers, I noticed that for the most part, every single choice was going to give you like an x squared, and then like a 6x, and it really just depended on the one that you were going to be doing later. So at least for these two, the difference of squares, that's important to know that these are difference of, well, not really. So when I was doing this, I noticed that for the most part, when you did these in your head, and you didn't have to do them all together, but I'll just kind of do one for you as an example, just to kind of explain what I'm saying, because I know that I'm kind of stumbling right now. When you distribute this and get it, you end up getting x squared minus 6x plus 9. The value of 6x here is positive, and since this is negative, and ignoring what's on the left over here, the plus 5 and the minus 5, there's no way you can get that, because this is a negative, that's positive, these two answers don't work. So now you're basically just left with A and B. The same thing is true for this factoring out when you have a positive, except that this now becomes the positive that we need. But now it's just about knowing if plus 5 or minus 5 will give you plus 4. Well, plus 5 will give you 14, so that's definitely not it. Minus 5 will give you 4, so that one works. The answer is B. So maybe there's a way of doing just like completely factoring that out and getting the answer right away. But at least for this problem, I kind of saw it kind of going through each choice and seeing which one was logical is the best way to find it. Let's look at number 8, because this one was also kind of interesting in my opinion. So it says, Ken is working this summer as part of a crew on a farm. He earned $8 per hour on the first 10 hours he worked this week. Because of his performance, his crew leader raised his salary to $10 per hour for the rest of the week. Ken saves 90% of his earnings from each week. What is the least number of hours he must work the rest of the week to save at least $270? So for this one, I kind of set it up as an inequality. That was the easiest way I knew. So I know that at least the one thing that's important to recognize about this problem, the $8 per hour for the 10 hours is independent from anything else that he makes, the $10 per hour. Because he made $80 at first, pretty much, and then everything else is just like a random variable because we don't know how much he had to work. The problem itself is asking what's the least amount he had to work when his salary was increased, because that's how to solve it. This kind of stays the same no matter how many hours you worked, because it was $80 at first, $8 per hour for the first 10 hours, and then at every point after that, it was an increased salary. It never went back to $8, so $80 is always going to be true. The rest of it can kind of just be solved like through simple interpreting the problem. So, and let me stop myself. I'm gonna write at the top so I have enough space. The keyword in this problem, another keyword, is what is the least number of hours in order for him to have at least 270. So that means that the sign is less than or equal to, because he wants to have more than 270. 270 is like his lowest limit. There's $80 over here that he got from doing $8 per hour for the first 10 hours. And now the rest, he worked 10 hours, he worked 10x or 10 hours, $10 per hour. Once you do that, it pretty much says that he wants to save 90% of his earnings from each week. So the way I did it, I noticed that at least when I was doing this, in order to get 90% of all the earnings, you would have to do like 0.9 or 90%. And pretty much what you're saying, and what I did in my example, for example, I just moved over the 190 to this side. I subtracted 80 from both because I know that this is just easier to see when that's on the other side. Basically, when you put the 0.9 there, it's pretty much telling you that when he makes his total amount, he only wants 90%. And the 90% should be the 190 because that is what he's saving. So let's see. It says at this point now, it's kind of just like a normal solving approach. You divide by 10 on both sides. Let me clear all of this because it's getting distracting. Sorry about that. Okay, so you divide by 10 on both sides, like I said, and then you're left with 19.9x. At this point now, I found it easiest to, well, there's many ways to do it, but you can divide by 0.9 on both sides. And when you do that, I'll try to do it on this side, just so it's kind of easier to see. It's the basic division that we learned again. So you move this over, you get 190. Remember to have the point up there. So when you do this, you're practically solving for x. So whatever you get over here, x has to be less than, or the number there has to be greater than or equal to that. So when you do this, you see how many times 9 goes into 19, because it doesn't go into 1. You get 2. You bring down the 1, you have 10. You see how many times it goes in there, 21, 9. It's going to be pretty much repeated, 21.111. So that means that he has to work at least 21.111 hours in order to get 90% of his earnings as the 270. So what I will say though is that at least for this problem, all the answers are in whole numbers. So it's important to note that he can't really work 21.111 hours in this scenario. So you have to kind of go up to the next closest number, which is 22. So that's kind of how I would do that problem. Moving on to number 9. It's already 12:23. So I'll do number 10 because number 9 is a good, it's something that we've done before. And I want to make sure that we get to the harder ones of this section. Number 10 is just kind of knowing the roots, which we did a few tests back. So it says in the equation above, a, b, c, d are constants. The equation has roots, -1, -3, and 5. So which of the following is a factor? So remember, your factors will look more like this, as you can see in the answer choices, but the root will be like the solution. Roots and solutions are the same thing. So the root or solution for this one would be x is equal to -1. And I kind of just randomly put the closest thing I thought of, and it happened to be the exact answer to this problem, because the root is -1. The answer is x plus 1, because -1 is what you plug in here, and it's what gives you 0. That is kind of like the key way to solving this. Which one will work and give you 0? All right. So going back to like the roots, just because someone in the chat box wanted another explanation. Let me see if I can explain it a different way. So let's say that you had like this as your problem: x is equal to -3, or x minus 3, x plus 6 is equal to 0. So your roots or your solutions, there's two ways to write it: roots or solutions. In order to find those, it's kind of just setting each of these equal to 0 and solving. So the roots for this would be 3 and -6 for this made up problem that I just wrote on the paper. For this one, it's not telling you to kind of reverse. It's telling you that the roots are, and let me erase all of this work. It's telling you that the roots of this, we don't even need to know the letters, the A, B, C, and D. It's just telling you those are random constants. It's telling you that the roots are -1, -3, and 5. So that means that for this problem in particular, in order to get the opposite, it's kind of just the opposite. So this would be x plus 1. This one would be x minus 5. And this one would be x plus 3. And I wrote 5 again by accident. So remember, the roots are kind of what you plug in to give you 0. So the reason why the root of this one is -1 is because when you plug in -1 over here, you get 0, and that's how you get 0 over here. But that's kind of how it works. So at least for this, now that we know every single factor, these are all called factors. It's kind of just easy now to pinpoint which one is correct. And x plus 1 is the only one we have there. X minus 3 is not there. X minus 5 is not there. And everything else is flipped. So that's how you do that problem. So hopefully that kind of made sense. I'm going to go on to number 11 now. So let's see that one. All right. I want to do number 11. It's already 12:26. There's a lot of good problems in this section. So I'm going to do number 11, 12, and someone asked to do 13 and 15, so I'll do those two. So let's do those, number 11 and 12. So it says the expression, I'm not going to even bother reading that, where x is greater than 1 is y and y is greater than 1 is equivalent to which of the following? So this problem. So at least when I was doing this, I did notice that it could be easier to kind of just move things around and simplify. So instead of, because I noticed that maybe I first thought when I looked at this problem, I was inclined to like simplify this in a different way and just put everything in the numerator, but that's not what it's asking for. So what I did was actually just I converted the radical forms of all of them, because I noticed that all the answers are in radical form. So I'll talk about the x to the -2 and y to the -1 later, but this simply becomes y, the cubed root of y, because if you remember, I'm sorry, I wrote the wrong letter, the cubed root of x. So when you're converting something in exponential form to radical form, you take the number on the inside, you leave it there, and the number in the denominator goes on the outside. But that just, x to the 1 is just x, so that's just the cube root, or taking the cube root, that's how you say it. And then for this one, y to the 1/2, I'll redo that on the top over here, it's the same methodology. So y to the 1 over 2, you leave the 1 on the inside, but you take the square root, because the 2 goes on the outside. So it's really just the square root of y. So at least over here, and you guys need to know that you don't need to write the 2 when you're doing it. You can just write it as the square root. So this just becomes that. So at this point, we now kind of have a better idea of how the answer will look. It's just about dealing with these, the negatives, because those are kind of harder to deal with. So let me, I'm going to do it in a different color, and I'm going to kind of explain what to do with those. When you have something as a negative in the answer, it's really just important to bring it to the denominator. So x, and I'll kind of just explain it for both. X to the negative 2, y to the negative 1. X to the negative 2 can just be simply rewritten as x1 over x squared. And x to the negative 1, or y to the negative 1, sorry, I keep mixing up my letters. That can just be written as 1 over y to the 1, which is just 1 over y. So let's kind of just put those into our equation, or what we have over here, because now it's all up to simplifying, and it can be weird to simplify things like that. So it's important to know the rules at least. So I don't have that much space, so I'm gonna erase this over here because we already know what they're equal to, and I'll rewrite it at the top. So the 1 over x squared goes over here, this square root of y is over there, and the cube root of x, and it's a 1 over y. So let's simplify that. When you have a fraction at the top, it's important to note that you can just put in the front too. So when you have that, at least for this first term that we're dealing with, this x squared can simply go in the denominator now. So at this point, now we have x squared, the cube root of x, 1 over y. It's just about getting rid of this 1 over y, because even though it's technically right, we don't like to have a fraction over a fraction. So at this point, you just need to know that we're not really getting rid of anything else. And whenever you have something like that in the denominator, you're dividing. In order to divide by that, you do keep, change, flip. So this is it could be done much quicker. I'm just going through the steps, but keep, change, flip ends up giving you this. So when you end up simplifying this answer, a lot of work I took up on the page, but you should end up getting y squared of y over x squared, the cube root of x. So there are many ways to actually come up, like at least kind of see this problem and solve it. But it's really just about knowing how to simplify the exponents and put them in simplest form, or put them in the answer that you'd like. So the reason I was doing that is because I noticed that they had all the y's on the top and all the x's in the bottom. That's why I put all the y's on the top and all the x's in the bottom. And the only answer that gives you what I wrote down is D. So I'm going to move on to number 12 is a concept we've seen before. So I'm going to do 13 and 15 just because someone asked to do those. So with 13, it says, which of the following is equivalent to x squared minus 2x minus 5 over x minus 3. We've seen this before. This is long division of polynomials and factors and things like that. So I'll go over the steps again and just make sure it's clear how to do it. So for this one, you just set it up like a normal division problem. Remind myself to do it all the way at the top of the page so there's no space. When you have a fraction, you guys know that it's division. So it's this, the top one, divided by the bottom. So it's x squared minus 2x minus 5 divided by x minus 3. And now it's just about going across the steps. You see how many times x goes into x squared. It goes in x amount of times. And now you multiply x by each term over here and subtract it from what's over there. So I multiply x times x, I get x squared, but I'm subtracting it. I multiply x minus 3, I get negative 3x, but I'm subtracting it. So it becomes a positive 3x. You're kind of just doing the opposite. Maybe it's easier to think of just multiplying these and then doing the opposite. So when you do that, you end up getting x minus 5 because these two cancel out. So you don't have to worry about that. Now we repeat. So we see how many times the first term goes into the first term over here. That's 1. And then we do what we just did. We multiply 1 times each of those numbers and do the opposite. So 1 times x, we do the opposite, minus x. 1 times -3, -3, we do the opposite, plus 3. You're left with -2. Now, -2 doesn't go into x. Remember, it's always the first term we're looking at. So that's our remainder. So these two are already wrong because we already have x plus 1 there, so we know it has to start with x plus 1. But with a remainder, you just need to remember that the remainder can be rewritten as this over that, because the reason why we can't do anything is because x minus 3 doesn't go into that, but it doesn't go into it evenly, but you can still divide by it and still represent it that way. So when you end up simplifying it, you should get this. And that is choice D. So again, that was a quick overview of how to do the long division of polynomials. I recommend using YouTube as a really good way to practice them, just because it's definitely a process that you need to practice and get the hang of, because it very well may show up. I've seen 2 problems like this so far, and yeah, it's important to know. So let's move on to number 15. Because that was another one that someone asked to do. So it says in the expression 1/3 x squared minus 2 can be rewritten as that, where k is a positive constant. What is the value k? So for this one, when I looked at this problem, I noticed that these are this format, ignoring the 1/3. This is the standard format for the difference of squares. When you have x minus 2 plus x plus 2, it's important to know that that is the format for the difference of squares. So when you multiply those together, this should just be x squared minus 4. So that is kind of going into like what we can get to get that. Because since this is the formula for like the difference of squares, the number here, when you multiply them together, it has to give you, it has to be kind of the same number in order to get this number over here. I'm gonna write it down just so it's easier to kind of picture what I'm saying. But I'm telling you guys kind of what I noticed when I saw this. So the first thing I really picked up on was that in order to factor, in order to get 1/3 in the front of everything, you have to factor 1/3 out of this, because clearly the 1/3 is just left to the side. They're taking it out of this expression. So in order to take that out, that's obviously x squared, but how do you get the 1 over there? Well, what number times 1/3 will give you -2? It's really just thinking what number divided by 3 will give you -2. That's 6. So at this point, and you can always just double check and do -6 times 1/3, it's -2, but that's just kind of how to do it. So at this point now, it's just converting it to the difference of squares format. We have the 1/3 on the outside, we got rid of that. It's now just about figuring out which number will work. Well, remember, in order to do that, you have to take the square, in order to get a difference of squares. The 2 numbers that are here, the k's, are the square root of the number over here. When I did the one that I just did right now, it was x squared minus 4. Remember when we factored it out, it looked like x plus 2, x minus 2. And that's kind of how it worked. So for this one, and remember, 4 is the square root of 2, so that's kind of how it works. So for this one, it would simply just be the square root of 6. Because in order to get 6 by itself, when you simplify this and kind of double check yourself, when we would redistribute this, in order to get 6 over here, there has to be radical 6 times radical 6, which will give you 6. So hopefully that kind of made sense. The value of k is radical 6, and I will kind of just double check it just so you guys understand how it works. So what I'm going to do now is just kind of prove the difference of squares and how it will give you this format. And my phone is ringing in my house, so sorry about that. So let's see. We have x and x plus radical 6. When you simplify these, you get x squared over here. You get radical 6x minus radical 6x, and negative radical 6 times positive radical 6 is just 6. So when you simplify those, you get x squared minus 6, and notice how it's the exact same thing as what we have over here. So that's kind of the math logic behind that problem. So I'm gonna move ahead to some of the long responses over here. Those are the best to do. We have 5 minutes. I really like number 17 and 18. And yes, so I'm gonna do number 17 and 18, and if I'll kind of show you guys how to do number 20, because that one was also interesting. So 17, it says in the figure above, MQ and NR intersect at point P. Okay, that's very clear from the picture. They're intersecting at this point right over there. And it says NP is equal to QP and MP is equal to PR. What is the measuring degrees of QMR? So whenever you have angle and triangle problems like this, there are many ways to do it, but I'll show you guys how I did it. So I know that MP and P are equal, so these two are equal. That means that this triangle right over there, PMR, that means that it's isosceles, because when these two sides are equal, it's isosceles. So that means that the angle over here is going to be unique, but that means that these two on these sides are going to be equal. Notice how the angle it's asking for, QMR, this angle is this one over here. Let me circle it. So I can use the logic of this triangle, PM, what did I write? I think I wrote P twice. Sorry about that, guys. This should be an R, and this is the triangle we're looking at. So for PMR, we can use the logic of just the triangle itself to find the missing side. And what I also noticed was that, oops, sorry about that. I noticed that the angle over here, this is a straight line. This is a 60. So when you kind of think about it this way, if this is 60, the other angle over here, since it lies on a line, it's a supplementary angle. So that means that these two angles there have to add up to 180. So that means this is 120. So that means the one over here is 120. So that angle is 120. So going back to the triangle logic that I was looking at, or what I noticed, I'm drawing this, like I'm drawing a bigger picture of it. We know that this is 120. We know that these two are equal, so we can just say that they're x. In order to figure out what x is, we know that 120 plus x has to be equal to 180. This can just be rewritten as 2x over here. You could move the 120 to the other side. You should get 60 over here, 2x. When you divide by 2, we get that each angle is equal to 30. So that is our answer. That's how much that angle is worth. And you don't have to do that equation form. I'm just doing that just so it's easier to see the logic behind it. These two are both equal to each other because they're isosceles. That will always be true about isosceles triangles. So you can just represent them as both x's, and from there you can kind of just solve and figure out what they're each equal to. So hopefully that one made sense. I like to target the geometry ones just because I know that they're harder. But let's look at number 18. It says the number of radians in a 720-degree angle can be represented as a pi, where a is a constant. What is the value of a? Okay, so for this one, it's just about knowing like the properties of a circle. So I will say that when you're thinking of this problem, it's important to know that when you have a 360-degree angle, you have 2 pi radians, and that's really important, especially when you're learning the unit circle. And I guess if you know the unit circle, it's easier. But one full revolution, 360 degrees, is the same thing as 2 pi radians. So if we were to double this and have 720, it would just be 4 pi radians. So that means that a is equal to 4, and that's your answer. There's really nothing else to it other than knowing that a full circle, a full revolution is 2 pi radians, and 720 is double that, so it's just 4 pi. So that's the logic behind that, but I thought it was interesting because I didn't see a problem like that before. So the last one, number 20. The reason why I want to do number 20 and number 19 is simple slope equations. Number 20 is interesting because it's another problem that requires a lot of tedious math, a lot of simplification. So let's try to do it really quickly and get the answer. So it's just about finding a and b as constants. And it's telling you that the simplified form should look like that, and that'll be a and b. And then it wants you to add a and b together. So let's first find a and b and figure out what they are. So we have 7, 5, 3, 2 plus 100y squared. And the thing that's really getting in our way is this over here. So let's simplify that. I'm going to distribute the 10 to both. 10 times 10y squared is 100y squared. And 10 times negative 110, it's really just about adding a 0. That's what 10 does. So it should be this. But if you're ever kind of unsure, you can always just do it on this side if you want to double check. So when you do that, you should end up getting 1100. And remember that it's a subtraction, so it's negative 1100. At this point, now it's about combining like terms and putting it in the format they want, which is ay squared plus b. I'll write it at the top. So when you combine like terms, you should get, and you can just do it in your head, but it should be 6, 4, 3, 2, and there should be a 200y squared. And to put it into more similar to that format, I'll put the 200y squared in the front and the 6,432 on the right. So now it's easy to determine what a and b are. It's just about matching them up. So at this point, now it's easy to see that a is 200 and b is 6,432. So now it's just about adding those two together. It's 200 plus 6,432. Your answer is 6,632. It's just about changing this to a 6. So that is the answer to this problem, and that is the end of this test for now. We did as many as I could, and hopefully that did help.